Okay, so we're going to move on. We tried our first attempt, but we realized it's not going to be best our best approach. So the second approach, we're not going to repeat those sums, those previous sums. So we have to now have a slight modification to the algorithm. So if we kind of write out the pseudo algorithm here, we've got now our maximum set to initialize to 0, our sum initialized to 0. We're going to take a sum of the segment. It's just going to be 4 in this case. So now the maximum changes to 4 because that's our new maximum, and the sum changes to 4. So we're keeping track of that sum now. Notice that's the big difference. So now we have a new segment. We just take the previous sum and then add on that next element. So now we get 1. So now our sum changes to 1. Our max remains the same. So now we get a new element, 9. So we take the previous sum, 1, plus 9, and now we get 10. Sum gets updated to 10, but guess what? So does our maximum, because now it's been exceeded. Now we take the very last element in our list. So we take our previous sum plus our next element in line, and now we get 5. So the sum changes to 5 here, but the max is going to remain at 0. Now we're starting over on a new list, so our sum gets reinitialized to 0. So I shouldn't say we start over on a new list. We start over with a new lower value. Okay, remember that lower and upper value? Well, our lower value is now no longer 4, but now it's -3. So sum gets reinitialized to 0. However, max is not going to. Max is still 10. And then just continue going through the rest of the list in the same fashion. So notice we're not summing the same elements over and over like we did before. So now we have basically almost the same algorithm written. It's just we don't have triple for loops any longer. We have the max so far. We're taking lower in the range of the length of L, just before length of the list. Sum gets initialized to 0, but now we only have this upper value in that range of lower up to the length of the full list. And we're, notice we no longer have that I. Instead, we're just taking whatever that upper is, so that we are always updating that sum and updating the maximum within this the second for loop. So notice those both belong to that. So we first update the sum and then check and see, do we need to replace the max? So far, once we've gone through both for loops, all possible iterations, we return the max so far. So syntactically it is more efficient, but more importantly, we've eliminated one of the nested do loops. Okay, so it still has some inefficiency. It'll calculate all segment sums starting from 0 by adding each element once, okay, instead of over and over. So it's an improvement. But besides the 0, this is exactly what you're going to be doing later when you start at 1. Like, a lot of the sums get repeated. Okay, and besides 1, the rest of that work is just going to be going back. You're going to be going back through all of that as you start with each new lower value. So it still has some inefficiency, but it's an improvement. So let's look at a third approach. A third approach is going to be looking at each element just one time. So this is going to eliminate in the past algorithm approach how we had to iterate through those partial sums multiple times as we went through each lower limit. We're going to avoid that in this approach. So it makes a single left to right pass over the full list, versus those awful and bad approaches made multiple left to right passes. The awful many multiple left to right passes, and the bad just less, but still a lot. So let's assume that M here is the maximum sum over all segments of this list here up to I. Now we want to extend this to the I plus 1 length. Okay, the key observation is that the only new segment we have not considered are those that end with Li. Okay, the maximum segment sum in Li plus 1 will be the maximum plus the maximum segment sum of those ending in Li. Okay, so if that doesn't make sense to you, let's take a look at the function. Okay, so here we're gonna again retain our max so far, but we're also gonna have a max ending here. Okay, so we can retain that previous value, max ending here, and then add on the next. Okay, I is gonna range across the length of the list. All right, so max ending here is going to be the max, well, initialized as 0, but the previous value of max ending here plus the current location in the list, or 0. Okay, then the max so far is just going to be that max so far that was retained from previous, or if this max ending here is bigger, because say you added on a positive number, then it gets replaced. So notice we only have one for loop here. So this should be, by all accounts, our most efficient approach. And let's think about what we get. And so notice with 3 nested for loops, not do loops. This is not our for loops. We get the worst times. With 2, we get an improvement, but it's still not great. With the single loop, we get the best approach. Now, of course, I would do this differently in R. So I think I wonder which would be faster. That would be an interesting thing to add here. But obviously you need to be a little tricky when you write these and think about the most efficient way to get through the algorithm. Usually your first approach, writing something, is not going to be your best.